clamp glass tubing onto a carousel. As it spins, torches heat the center of the hollow glass, while below, the operator pumps air into it. This causes the melted glass to blister. They break the tubing at the blister, creating two tubes with funnel-shaped openings. They anchor a shorter glass cylinder on a turntable and suspend one of the funnel mouth tubes above it. The tubes spin in concert as torches melt them together. The funnel ensures that the melting doesn't close the hollow tube. Another torch now aims further down the cylinder. It seals the end and shapes it into a ball. To test a sample of the production run, they heat the entire length of the tubing. This creates vacuum pressure, so that when they place the open end in liquid wax, the tubing sips it up like a straw. By watching the liquid ascend, they confirm that the thermometer fills as it should and has the right dimensions. Next, the glass tubing swirls on a carousel as flames and forced air work together to form a longer blister. Again, they break the tubing at the blister. This blister creates openings that allow them to snake a narrow, hollow wire through the tubing, joining the two sections. Flames melt and seal the glass around the wire. This is called a glass-to-metal weld, and it creates a more flexible thermometer. They cool the welded glass and wire on a conveyor. Next, they turn on a vacuum pump for several hours to pull the air out of the wire and tubing. This draws the blue liquid wax up, but this time it's not a test. The wax is a non-toxic alternative to mercury that will expand and contract with changing temperature. The thermometers now travel through chilled alcohol, shrinking the blue liquid down to the closed end of the thermometer. As the tubing turns, flames follow the top end to melt and close it. A heat gun below then drives the liquid up the tubing, and the air pressure creates a bubble in the end that was just closed. This bubble will be the thermometer's expansion chamber. They plunge the thermometers in ice water to calibrate the bulb liquid to 32 degrees Fahrenheit. They scratch the glass at that mark. Next, the thermometers warm up in a bath set at 200 degrees Fahrenheit. The blue liquid shoots up, and they make another scratch. They align the two scratches in the thermometer with markings on a printed grid. The distance between the two scratches often varies, so by measuring against this grid, they can calibrate the thermometer. They then match the thermometer with a corresponding scale. They install the top section of the thermometer in a case, which can be metal or plastic. They then choose the appropriate scale and slide it between the glass tubing and case. They wrap part of the wire capillary around a joint and then cap it. The sensor bulb of this thermometer will be used to gauge the temperature inside industrial piping. So they protect it with a metal sleeve called a bulb chamber. A glass window slides easily into the grooves of the casing. A plastic cap is the finishing touch. And now these thermometers are ready to gauge the highs and lows of industrial processing, and they're sure to measure up to expectations.